So in this example, we're given a function. As usual, we're given it as a formula. G of x is equal to 3x minus 4 over x plus 5. In other words, G is the process, the verb, if you like, of taking an input x and multiplying it by 3 and subtracting 4, and also adding 5 to it, and taking the quotient of those two quantities. So we know what G does to its inputs. So the question is, find and simplify the expression G of x plus 5. So what's our strategy? Just like when we were substituting numbers, we're going to use the very same strategy as before. The only difference is that because we're not substituting a number into our function, but we're substituting a variable expression, that means that we can expect that our final answer will not be a number, but our final answer will also be a variable expression. So our final answer is going to have x's in it. It's not just going to be a number, most likely. But because the strategy is exactly the same, we can borrow the same steps that we have before. To evaluate a function, replace the x in the formula which defines it with the input that you want everywhere that x appears, using parentheses every time you make one of those substitutions. So we're just going to, every place x appears in the formula which defines G, we're going to replace it with the input that we want, which in this example is x plus 5, using parentheses. Then all we have to do is simplify the result, which is going to be an algebraic expression. All right, so again, what is a function? A function is a machine. It's a process. It's a verb. It's an action. It's something that happens to a quantity rather than a quantity itself. So in this example, G is the function which takes an input, let's call it x, and which constructs an expression, 3x minus 4 over x plus 5. So whatever we put into G is going to get thrown into this template, 3x minus 4 over x plus 5, in place of that x. So in this problem, if this is what G of x is, again, we read it as G of x or G applied to x to remind ourselves this is not multiplication that those parentheses are indicating. It's the operation of a function. And what we really want to operate on in this problem is the input x plus 5. So we're going to use x plus 5 as the input to this function, but being very careful to hug that input with parentheses, especially so because our input has multiple terms in it. That x plus 5 all has to travel together. If we don't hug it with parentheses, there's a chance that the x and the plus 5 are going to get separated. We don't want that. So whatever happens to that input has to happen to the whole thing. So we're going to hug x plus 5 in parentheses and then make our substitution. Because G of x is 3x minus 4 over x plus 5, G of x plus 5 is 3x plus 5 minus 4 over x plus 5 plus 5. Hugged with parentheses, that expression is what we're going to call G of x plus 5, or G applied to x plus 5. And the function evaluation, the substitution step, is now done. All we have to do to finish up this problem now is just to simplify the expression that we got, which we can do by distributing the multiplication by 3 up in the numerator across the addition inside the parentheses. Again, this is why, again, the parentheses were so important. If we didn't have them there, we might forget to do this step. So 3x plus 15 is what we get out of that distribution, minus 4. Now downstairs, x plus 5, those parentheses are not actually serving any particular grouping purpose. Why? Because the only thing that's happening outside of them is addition. They're not being multiplied by anything, and so we just have two addition operations happening in the denominator, separated artificially by a set of parentheses. And according to the associative property of addition, those parentheses are unnecessary. So we can just get rid of them. And to finish simplifying, all we have to do now is combine whatever like terms that we have in the numerator and the denominator. Upstairs, our like terms are the 15 and the minus 4, which combine together to give me plus 11. And downstairs, the 2 plus 5s combine to give me plus 10. So this is typical of a problem where we have to substitute a variable expression into the input of a function. First of all, it's the same substitution process that happens if we were to try to evaluate a function with a numerical input. The only difference is that we can expect that the answer probably has variables in it in this example. How do we do it? Well, all we have to do is remember what it means to evaluate a function. It means to substitute for that x which defines the formula for our function, the input that we want everywhere that x appears. So because g of x was 3x minus 4 over x plus 5, g of x plus 5 is 3x plus 5 minus 4 over x plus 5 plus 5. Making that substitution and making sure to hug that x plus 5 input with parentheses gives us an expression which we can then simplify to figure out the most simple expression for the result of applying the function g to the input x plus 5.